It's not school district. It's county education grant. That's what it's called. County education. Thank you.
So I still like that all water so much strength. The FDA allows bugs and vinegar and peanut butter. Since we live on a finite resource, all water's already been drinking at least once. The FDA anything bugs and rodent hair and peanut butter.
Cedric?
Your drink has already been drank.
She slept over last night and then the same lunches as
It's fun because people don't realize that. Like, it's not a big deal.
What?
All right, let's see this. I'll bet you money that at least half of your scary facts. Raise your hand if you have a scary fact, by the way. Scary or shocking. Raise your hand if you have not completed the warm-up yet.
I'm looking.
So 2 people haven't completed it, but 15 of you didn't raise your hand. How does that work?
We haven't written it all down.
You don't have to have it written. Just using your phone, how many of you have found a scary or shocking fact?
Oh yeah, that's what. Yeah, that was mine too.
Don't get strawberry start.
It's strawberry milkshake.
Okay, now me. My hunch is at least half of the things that you find scary are some sort of contamination in your food supply. By the way, are we filming over there too?
Yeah.
Raise your hand if your scary, shocking fact was some sort of contamination.
Kind of.
Like the bug parts / insect poo / pubic hairs in your food supply.
Yeah.
Oh, you did the fast food pubic hair.
Yeah.
I started talking about on Twitter.
Quickly, just say pubic hairs in hamburgers or other things that are contaminations.
The average yearly food intake contains 12 pubic hairs.
Okay, what else?
The average human's yearly food intake contains 12 pubic hairs.
That is a fast food intake.
It just said food intake on the website.
No.
Oh, it's a fast
How do you eat your damn food?
You probably eat less than the American average for fast food. This is a fairly healthy community. So there's that. You're probably 6 or 9. Who else had a scary contamination in their food? Quickly, raise your hand and do it.
Oh, I didn't write that one down.
Who else had one? Scary contamination in your food? Yes?
The FDA allows an average of 30 or more insect fragments and 1 or more rodent hairs per 100 grams of peanut butter.
Okay, 100 grams is not a lot of peanut butter. That's like a spoonful. Who else? Who else? That was it? Yes?
Water ingredients.
Are you dying? I don't think you've got the stomach for this. Next.
Water ingredients. So basically, an almond of the water you've been drinking has already been dumped by someone else, maybe even more than once.
Right. And it goes into a river somewhere. Like, people who live along the main rivers in the United States are drinking urine that was urine that was urine that was urine before it, after it was rain.
I'm
Anybody else have one? That was it? I'm not very impressed. Yes.
Strawberry milkshakes contain more than 50 different chemicals.
Sounds exciting. Yes. I did the experiment where I put a tooth into Coke as one of my science experiments, like in school, you know, like for the science fair, and it was like gone, totally gone. And you know the funny part? I thought that the enamel would wear away from the filling, but the filling dissolved first, which kind of makes me think like you think you have fillings that are keeping you safe, but every time you drink Coke, your fillings are fizzing apart, and so the cavities get worse. That was back in the day of amalgam fillings. Modern ceramic fillings may be different. Anybody else? Yeah?
Yeah, I can't remember this one.
Vanilla, strawberry, raspberry. Flavoring comes from a beaver's anal gland.
Now, I don't think that there's like a factory where they milk beaver anal glands to make all of our flavorings. I think that just means that that's how we synthesize. Like we're inspired by that chemical. Because there's not that many beavers, so I don't think that we could get all that flavoring from beavers, no matter how much anal gland they have. I mean, that'd be a lot of flavoring. Like you see trucks of that flavoring driving around. Like that's a lot of beavers. Okay, so I guess that's it for our scary facts in contamination.
Oh, well. This one's not a contaminated one, but it's like botulism can grow in like canned foods, and then if you eat it, you die.
Yeah, it's an unfortunate roll of the dice. That's always an option with any stored foods.
What's botulism?
It's like a bacteria that kills you.
Yeah, deadly bacterial infection. Yeah.
Is it different with organic food and non-organic food with like the contamination?
Probably not
Like
significantly.
with peanut butter?
I wouldn't imagine. Now, there is one thing I got to tell you about these contamination things. You can avoid it. Just don't buy stuff that other people have processed. Like if you get your apple and it's like a whole apple, you just like rinse it under the sink. There's no way that there's like pubes and rat hairs and insect parts inside of your apple. And then you can just eat it and you're good to go. You know, like if you buy your own wheat berries, just like shake them out and then grind them in your flour and then you make your bread, that's good to go. Like if you grind your own hamburger, that won't have pubes in it unless you messed up.
So pubes are all I need.
And so the one thing I want to remind you in terms of contamination is how would you avoid this when you've got like 100 people touching your food before you get it? Like simply, for me, this is the, people asked me about my own food rules yesterday. I don't like the idea of like factories with people that aren't very committed to like providing me with healthy food, you know, like your average food factory worker is just like punching the clock and hating their life and then punching the clock. Like, I don't want that person to touch all my food. Just saying, like if you buy stuff that comes in a bag or in a box or in a bag inside of a box, like there's probably been however many dozens of people that had no interest in you touching that food. You know, or just like coughing over it or scratching themselves or whatever. Okay, so contamination, processing. Another round of your scary or shocking facts are probably just conspiracy. Does anybody have one that sounds like a conspiracy theory that may be bogus, like alarmism? Yes?
Cherry cheese is dyed orange.
Okay, that's probably a fact. Yeah, I don't think that's a conspiracy. It's dyed orange. Yeah. Yeah, so cheddar's not technically orange. It's the color that they add to it. Cheddar's white. Who else has a fun fact that might be conspiracy? Nobody? Yes?
Oh, no. I'm not sure. It says deer kill more people than sharks, rattlesnakes, spiders, horses, cows, jellyfish, and dogs in the U.S. combined every year.
Oh, I'd buy that. Yeah. Falling furniture kills more people than terrorism in the United States. Oh yeah.
On like an annual average.
Yeah, because there was one year when we lost a lot of people, but that was kind of a
You gotta
unique
start
year.
anti-couch.
Yeah.
Russia has a bigger surface area than Pluto.
How is that food fact?
How is that a conspiracy?
So where does food
Okay, fun fact, thank you. Yes.
Milk is a chemical that can cause cancer.
Fun fact!
anything can cause it?
Fun fact! Fun fact! Fun fact! How many of you found some sort of, as you were reading, you skimmed something about things that cause cancer? You probably saw it in your Google search screen, right? Now here comes the critical concept. This is not just AP Environmental Science. This is how not to be an idiot. Remember this for the rest of your life. There are two separate variables. Is it a potential carcinogen? And number two, how much are you getting? Does everybody agree with me that cigarettes cause cancer?
Yes.
If you take one drag off one cigarette, inhale that thing, hold your breath, let it out, and throw away your cigarette, you're not going to get cancer. Because yes, cigarettes cause cancer, but you have to smoke kind of a lot of them. Do you agree with my point? Milk may have ingredients that cause cancer. Probably not enough to give you cancer of those ingredients.
Everyone would have cancer.
Yeah, if not, we would basically, you know. The thing about does it cause cancer is only half. The other one is radioactivity. Like, do you all realize that you have a few radioactive atoms in you right now? All of us, we have a few. We have like trillions of other atoms, so you don't have to worry about it. You would need a lot of radioactivity for it to affect your health. We're all a little bit radioactive. A banana has much more radioactivity than any other food, but that's still not nearly enough to cause you problems. Sleeping next to another person raises your exposure to radioactivity. Just not very much. It's kind of irrelevant. The point I'm trying to make, if I could move on, the things that cause cancer don't necessarily cause cancer for you unless you have enough of them. There's a potential outcome, and then there's a dosage question. Like if you all go home and you snort 1/1,000,000 of a milligram of meth, I think you'll be fine. Remember I said 1/1,000,000 of a milligram. I said 1/1,000,000 of a milligram. Yeah, okay, fine.
Don't take this the wrong way. If you guys go home and do more than 1/1,000,000 of a milligram, then that's just...
Right, if you do any more than that, you're going to go straight to hell and die in the gutter. But 1/1,000,000 of a milligram, you'll be fine, because my point is that dosage is a big part of these questions of what causes cancer. Okay? Everybody freaks out about there's cancer-causing ingredients in my food. Of course there's cancer-causing ingredients in everything everywhere. That's not enough to cause problems. You can kill yourself with water if you change the dosage. Some lady did, no joke. That lady in the contest on the radio.
And how much is too much?
Water? Probably enough that you would be like so bummed out before you got there. But if you pound something like 60 gallons in under an hour or something, it's like an absurd amount. It affects your like ion balance. You can't hold on to enough ions for your nervous system to communicate. Yeah, it's kind of challenging.
Wouldn't that just like fill all the way
Yeah,
up?
yeah,
I'm not
exactly.
out before you
I don't know.
reach
Okay, this is a stupid conversation. We're getting stupider. Stop! Any other? Now what I want to know is, none of you really get the facts I'm looking for. I've done this for years, and so I realize I want to talk about the contamination and the conspiracies, but... Did anybody find a fact that's actually scary about food systems in this sense? like, oh my God, this is the country that gives us our food, and this is how we get it. And
Like hamburgers are made in factories where like tons of different types of cow meat are kind of put together, so that if one cow's sick, it's spread everywhere.
yeah, so the average hamburger in a fast food joint has DNA of more than 100 cows. And so if you think about it, eating a hamburger from a single cow versus eating a fast food hamburger, you've got 100 times the chances of getting sick from a commercial hamburger because it's got 100 cows that just want it. I find that to be kind of a scary one. But that's sort of bordering on the contamination. I'm not sure if that's kind of a food system issue. What else? Anybody have another food system issue? Yeah?
You'd have to walk for 7 hours straight to burn off a supersized Big Mac meal.
Dang. I think that's kind of an absurdity about our food supply, but yeah, I know people who eat 2 Big Macs a day. Can you imagine? Like, you just have to go walk from dawn to dusk. Like, yeah.
The USDA allows you to be made with ammonia. What is it called? And they don't make companies employ containers.
Yeah, meat. Yeah. No, the good news is ammonia turns to gas, and so I think if you do the right type of cleaning, that may not be a problem.
Yeah.
That might not be a problem for you. Like, technically, like, if that ammonium is otherwise clean and turns to gas before you get it, I don't know that that would actually be hazardous. I don't know. Could be. Anybody else? Any other facts that are interesting? You picked up a lab in the back. Separate the 2 pages, please. This whole unit, students will be confused. You'll notice one of those labs is salinization, the other one is soil. Soil lab and soil salinization lab. You see they have 2 different names, right? Soil and soil salinization. Please look up. The salinization pre-lab is due this Friday. The soil lab prep is due next Thursday. Just so you know, they're 2 separate labs, 2 separate due dates. Don't get them wrong. They're not interchangeable. Now please look up. For the soil lab, you need to bring, like it says in the directions, about 2 cups of soil from around your house. No wood chips and stuff, just soil. We need wild soil, like what's in the ground. Not like bagged soil from the garden center. Are there any questions about that? Somewhere near your house, no leaves or mulch, just naturally occurring soil from the ground. Please ask a question if you had one. Yes?
Is it which lab is this for?
That's for the soil lab.
And when do we need the soil by?
On the day that it says on the whiteboard that I'm pointing to right above my finger right now, I'm touching it. I want to have a penalty for kids that don't read the board. I think from now on, if you ask something that's written on the board, I get to kick you.
You're like an airsoft or something.
What?
An airsoft.
Oh yeah, that's a good
You mean like a rock inside of a sock? Excellent. Yes.
Airsoft.
Is there another question?
Butter in it.
Good. Then this Friday, the salinization lab is due. For the salinization lab, please look in the back. You'll be building one of these, which is 6 different petri dishes with paper and different salt waters and seeds to see how the how the salt content of water affects the sprouting of seeds. Questions about that? This introduces a new concept you may not know about my class. So now I have to tell you about this concept in my class. From now on, now that we're getting to the more nitty-gritty units, from now on, whenever we have a lab, you'll have to do what's called a pre-lab or a prep and a post-lab or an analysis. One you do before, then you come to class, then you do the other one after. So pre-lab or a prep, you do as homework, then you show up on the day of the lab when we do stuff in class, then you go home and you do like a data analysis or a post-lab or a conclusion of some sort. Listen very carefully. This is new to our class from now on all year. On the remaining labs of this school year, you must write your own instructions, because when you walk in the door, you're not allowed to use my printout. If you got to cut something out, like a data table or this triangle, you're allowed to cut and paste. But you must, listen very carefully, have written your own instructions, like which materials you need and what you're supposed to do and which data you collect. Yeah.
Is that what the pre-lab is?
That's the pre-lab, right. Because you need to prove to me that you know what you're doing when you walk through the door. Newsflash. When you go to college, they don't tell you what to do for the labs. Sometimes they'll show you how to use something, or they'll show you some little bit. But in university, when you go to science classes, during the lab section, you walk in and you do your stuff, and you don't leave until it's done. And there might be some TA sitting in the corner reading the newspaper or something. But you just use the lab independently, and that's how my class works. Except we only have a 57-minute period. I hope it makes sense to everybody. These labs are all roughly 1-hour labs. So when you show up, you got to be ready to bang it out so that you can finish during the day. Does that make sense to everybody? It's your job before all labs, when they say lab prep or pre-lab, you see that? They're both written up there. For pre-labs or preps, you read the whole thing, write your notes so you know what you're doing, and on that day when you walk in, if I see these, I take them and recycle them. You're not allowed to use my handout. This forces you to know what you're doing before you walk in. If you have questions, you can ask me before the day of the lab. That's why I'm giving it to you on a Tuesday and it's due on Friday. If you have questions, you can ask me before Friday. What things go?
Do we have to write all the background information?
Just what you need to run your experiment. So as long as your instructions work for you, that's all you need. Like your homework, all you need is what your notes are. But remember, like, you're going to be working from those notes. You may not be able to pick your lab partners. Most of our labs, I pick your lab partners. So the challenge for you is, what if you're the only one in the group that knows what they're doing? Like, you might show up and think like, oh, Austin's got this. And then if Austin's in a different group, then you needed your notes. You know what I'm saying? Speaking of Austin.
Are these going to be stamped?
The pre-labs are stamped.
Okay, cool.
If you have them. Any other questions about the pre-lab or preps? Yes?
For the soil, do you want like 2 separate areas of soil from around your house, or just like can they be 2 cups from the same
Each person
spot?
must bring a single 2-cup sample from one site near their home. Any other questions? And take a look when you're there. You might want to take a photo with your cell phone. I'll ask you some questions about the place. So you take like a panoramic shot of like the zone. That might be easier than trying to write down notes about it. Anybody else? Where did we leave off in the movie yesterday?
20.
I'm sorry to do this to you. We're going to finish that movie today. There's a couple sections of really rushed note-taking. And if my son is sick enough tomorrow, I might have to stay at home and you would be watching a separate film back to back to back tomorrow. Sorry about that.
So my Sue has your grant thing. The secretary took it and she's going to give us the principal's not going to be in the entirety.
The principal's not here all week. And where was Meister when you went?
Apparently he was just like talking with his family or something like that. I don't know what he was.
Yeah, but that's still they heard enough. I get something. You don't want to hurt the kids.
Yeah, but late, dude.
What do you mean?
It's like, it's the 21st and it says it's on Friday.
What if you come out of class and you see your friends like pink?
I'm not worried about it. But I do need that paper set, so
Hopefully colleagues and senators off.
maybe at the end of the period you could just go do a little quick drive-by and be like, hey, did that by any chance get handled yet?
That's true.
Does anybody have any questions for me before I launch our movie? Warning, whenever they discuss problems and solutions, if it's at all relevant to your study goals, make sure you write down all the words.
It's just number 33. 33 is really like 40.
Yeah, that's like a whole study assignment. Ready, set, go.
33 to 46.
The spraying kills both hoppers and spiders. Peter Kenmore of the UN Food and Agricultural Organization was working in Indonesia at the time and recognized the problem.
The natural biological control in those rice fields was destroyed, and the pests were allowed to reproduce without restriction, and this is called resurgence. You spray, and the pest populations flare back.
Soon, farmers were spraying constantly.
The spray was carried out not based on numbers of brown hopper. They just spray according to calendar schedule. For example, once a week at least. Now, if there is still brown hopper around, they apply more frequent spray, 2-3 times a week. Sometimes twice a day, in the morning and the afternoon. Too much pesticide.
The crisis reached such proportions that in 1986, President Suharto himself prohibited the use of 57 pesticides on rice. Only 9 were permitted, and they had to be used in a new, more naturally based system called Integrated Pest Management, or IPM. The Green Revolution had to be salvaged. An army of government teachers began introducing IPM to millions of farmers across the country. The message? Don't depend on chemicals to destroy the hopper. Use natural methods instead. And the first step? Go back to crop rotation. To disrupt the hopper's reproduction, Indonesia once again started growing crops other than rice for 1/3 of the year. A television spot from the Philippines shows the next step. Protect good insects.
I listen to this song every year and I love it now.
The idea of IPM is to work with nature, and that means farmers have to get to know their fields. They have to recognize beneficial insects, keep track of hoppers, and only spray limited amounts of specialized chemicals. IPM is not easy. Only 5% of Indonesia's farmers have been trained to use it so far. But their pesticide use has dropped by 75%, and their yields are going back up. These methods are more than just a new formula for growing rice. They're finding application in many different types of agriculture around the world, and they combine modern knowledge with traditional wisdom, where the resources of the land, like beneficial insects, are recognized and encouraged. Peter Kenmore sees 2 benefits, one financial, the other less obvious.
Insecticides can represent anywhere from 5 to 20% of the cash costs of rice production, depending on where you are in Asia. And using IPM cuts that down by at least 50% and often by 90%. We thought that was the most important thing when we first started training farmers about 7 years ago. We were wrong. What we found out was that farmers were much more motivated and much more excited about new knowledge, about understanding what was happening in their rice fields, about understanding natural control of pests, so that they had a peaceful feeling about that rice field. They weren't afraid.
There is perhaps no land more devastated than this by lack of understanding. It was once the lush prime rangeland of northeast Australia. Brian Roberts, a leading soil conservation expert, is painfully aware of his country's dubious distinction.
We do hold the world record in terms of the amount of land that has been damaged by such a small population over such a short time. We have damaged something like 11 acres per person, as opposed to the American figure, which is about 3.5 acres.
In the search for higher yields and higher profits, the world's farmers have been taking more and more from the land and putting less and less back. Nowhere is that better illustrated than here. Many ranches are so vast, several 100,000 acres each, that helicopters are used at roundup time. Charlie Hayward raises thousands of cattle a year for Australian and American markets. When he bought this ranch 10 years ago, he thought much the same way as the first settlers did about this rich, seemingly inexhaustible land.
The basis of the early settlers was cheap land. The most important thing was to occupy it. And then, of course, there was no management. It was fertile, virgin land that had everything in it that nature could produce.
There's an old saying here: if it moves, shoot it. If it doesn't, chop it down. That's certainly what the European settlers did 100 years ago. In these parts, they tore down the trees to plant imported grasses for cattle. Grasses that grow faster than the native varieties. The problem is, there are droughts in these parts too. Every few years, large patches of grass, native or introduced, burn out. And whether the range can recover or not critically depends on how much stress the cattle then put on it. In recent years, ranchers in the area have seen that with each new drought, less and less land comes back. Most ranchers attributed their grass problem to bad luck with the weather. But Charlie Hayward suspected their management was at fault. So for a rancher, he made an eccentric move. He took a correspondence course in soil conservation, and then invited the instructor, Brian Roberts, to see the situation firsthand.
Now, are these bare patches moving back? Do you find that these tufts of good grass are in fact weakening and moving back? Is this humus disappearing?
Yes.
What do you reckon?
It is in some places.
The bad news for Charlie was that the biggest problem on the ranch was simply too many cattle, and that was made worse by the introduced grasses, which can't recover as easily from drought. The process was simple. The grass was eaten so fast that it couldn't reseed itself. When the rains came, there was nothing to hold the precious topsoil in place. A single inch of soil takes 500 years to form. The ranchers were dumping their land into the ocean at an impossible rate. Now Brian Roberts is offering advice on what to do next.
So we've got to do something to firstly prevent the water getting in at a velocity.
Even washing your fences away.
That's right. Yeah, look at this.
About a third of the region's grassland has been badly damaged, and the best advice Brian Roberts has to offer is that the ranchers should cut back their herds.
In the past, most people have tried to maximize their animal numbers, but it's quite clear that if they reduce their numbers by about 1/3, they get better fed animals, higher calving percentages, and do much better in the droughts.
The Australian ranchers, in their search for high yields, came up against environmental limits, just like the limits which Indonesian rice farmers encounter. Yet how simple it can be to avoid disaster. Here it's a matter of reducing the animals, and rotating them onto different sections of range. And Brian Roberts is suggesting another step. He's encouraging reseeding in the most damaged areas, but this time with the original native grasses. They work better here, in the same way a rice paddy works better with its natural beneficial insects. Now, for Charlie Hayward, this is the way the land must be treated.
It's not going to be any pleasure for me to see this devastating thing happening and not doing a thing about it. And if we don't all get together and sort of attack the thing, both departmentally, governmentally, taxation-wise, and technology-wise, if we don't do something about it, we are committing a sin.
It's a mighty hard road, and our poor hands is full.
In the 1930s, it was America that was committing the sin. 40 million acres of the Great Plains turned to desert. The Dust.
How many of you have heard about the Dust Bowl? Okay. There's this unfortunate problem. We just finished number 35. We're about to start number 36. But in this section, they do this like rapid fire 4 terms that are ways to conserve soil. And then they give you like a very rapid fire explanation of those 4 terms. It's like super rushed. Sorry, giving you a heads up. It's almost impossible to take notes on those. So I'll play it, then I'll rewind it, and I'll play it. But get ready, because they just throw out these 4 vocab terms that become really useful later.
As in Australia, drought combined with abusive farming practices were to blame. During the First World War, farmers had expanded production onto steeper slopes and skipped rotation crops, leaving fields open and vulnerable to the devil of soil erosion, as the government films put it.
I've been getting away with it for centuries. Who's going to stop me?
We will. What you've stolen, we're putting back with soil-building crops, terracing, strip cropping, contour farming.
No.
And we're all ready to help.
That was a close shave. Bang.
Treat the land better, farmers were urged. Stop water erosion by plowing along the slope, not up and down. Plant in strips, so no large areas of soil lie exposed to the wind. Go back to crop rotation. Plant crops that help soil fertility. And within a decade, the land was back in condition.
They just actually gave you 4 vocab terms and then defined them.
Terracing. I have a question. Strip cropping.
What is your question?
36. Well,
it's about Africa. It's not about America.
That's right. And so unfortunately,
as in Australia,
we're in the transition where they talk about erosion. Okay, now, I can answer that question and give you what you're looking for, I swear, just bear with me. First of all, we did just finish Australia, number 35, correct. Number 36 is about Africa, correct. And in the middle, they're like, oh yeah, there was this thing called the American Dust Bowl. Drought and farming practices didn't mix very well. All the dirt blew away from America's Corn Belt / heartland. Sad days. Okay. Back to me now. This video, in discussing the Dust Bowl, introduces 4 methods of avoiding erosion. Here they come. You should write these down.
Who's going to stop me?
We will. What you've stolen, we're putting back with soil.
Number 1, soil building crops. See it right there, sort of. Second method.
Build crops. Terracing. Strip.
Terracing And strip cropping, that's number 2 and number 3. Terracing was number 2. That's how you spell terracing. I looked at one of my students' papers today, and she had written Terrence, like the name. Like, hi, I'm Terrence. Okay, so terracing.
Strip cropping.
Strip cropping is number 3. And finally, number 4. Contour farming, which is usually called contour plowing. So contour farming / plowing. And here's what those things mean. Now they will define them.
And we're all ready to help. That was a close shave. Bang.
Treat the land better,
Here comes one of
farmers
them.
were urged. Stop water erosion by plowing along the slope and not up and down.
Plowing along the slope. That's contour farming. You'll be all right, relax. This is contour farming. Look at how it's plowed. Do you notice how that's sort of irregular? It's not like a grid. Like when you drive past the berry fields, they're going like up and down the hill. Understand what happens. Look at me. When you plow uphill and it rains, what do those tire tracks become?
Streams.
Gutters, streams to take away dirt. So when you plow uphill and downhill, you get gutters that cause erosion. Instead, you can do this, plowing along the contours, and that saves your soil. This is contour farming, or contour plowing. Questions? Next.
Plant in strips so no large areas of soil lie exposed to the wind.
So this is strip farming, where you plant in strips so the wind doesn't have huge chunks of dirt to carry away. So you limit water erosion with the last one, and you limit wind erosion with strip farming. You can do this. I'm going slow. I'm spelling it all out. You should be writing these down. Contour plowing to limit water erosion. Strip farming to limit wind erosion.
Go back to crop rotation. Plant crops that help soil fertility.
So planting crops that help soil fertility, that's the soil building crops. Crops that help improve fertility. And there's one that they don't discuss here, but they told you the concept. What's the one that you haven't filled in here? Terracing is when you make a hill into steps, like this. Look at me. Step, 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 instead of a hill. So they're called terraces. Does anybody know what terracing is? Where you like level hills into steps, create many levels instead of one slope. Okay. Then now we're going to start number 36, where they talk about Africa and how they avoid erosion. And you'll have to write down those methods. So this is like also erosion avoidance. It's other erosion problem solutions, just not in 35. We'll come back to these, I promise. Remember my advice was record all the vocab terms and record all the numbers. You'll see where these become important.
And within a decade, the land was back in condition. But good stewardship didn't last. In recent decades, as world food demand has grown, many farmers have dropped soil conservation practices. The result? Erosion is once again common on American farms. But why aren't farmers worried about losing their topsoil? The answer is simple. They can make up for lost fertility by adding more artificial fertilizer, at least for the short term. All over the world, farmers are doing the same, but nobody knows how long it can continue. From the World Watch Institute in Washington, Lester Brown.
We're now losing about 24 billion tons of topsoil each year, in excess of the rate of new soil formation. The world's farmers must therefore now try to feed nearly 90 million more people each year, but with 24 billion fewer tons of topsoil than they had the year before. One does not have to have a degree in agronomy to know that these two trends, population and loss of topsoil, cannot both continue indefinitely. We are now approaching a time of reckoning.
This is the Sahel region of Africa, just below the Sahara Desert. Here, Lester Brown's time of reckoning is right now. Population is going up, and soil fertility is going down. In the last 20 years, food production per person has dropped by 1/5. The land is overstressed. In traditional farming here, a field was prepared by burning vegetation. After that, it was planted for a few years and then left to recover for at least 10 years. But now, farmers are using the same land year after year. Fertilizers would help, but they cost money, and they need water to make them work. Both are scarce. At the same time, trees are disappearing, both from increasing numbers of animals and increasing demand for fuel. As pressures on trees increase, many people turn to animal dung and leftovers from crops to burn in their cooking stoves. Resources that would better be used to fertilize the soil. The result is the Sahel's own Dust Bowl. The soil is losing its fertility, and it's blowing away. Just like in America in the 30s, or Indonesia more recently, the land has been pushed too far. And like Australia, the process has been aggravated by drought. But that doesn't mean that the situation here is hopeless. This is one of the most effective things to do. In a valley in Niger, the international aid agency CARE helped set up a program to plant avenues of trees, over 400 miles of them. The trees hold in moisture and protect the crops and soil from the wind. Sorghum and millet are the staples, crops adapted to dry conditions. Their yields are now up about 20%. Windbreak trees were also adopted after America's Dust Bowl, although many have since been removed. The Green Revolution's new crops need fertilizer, which needs water to work. So it bypassed Africa's dryland farmers. But less dramatic projects like this can still make a big difference.
We benefited a lot from the trees that were planted on our farms, and our lives improved a lot. Crop yields are much better now than in the days of the terrible dust storms.
The windbreak trees provide another benefit, firewood. As long as they're not over-harvested, they'll relieve pressure on trees throughout the valley. The environment here may get a chance to recover. All over the neighboring country of Burkina Faso, there's another simple but effective project underway. It's also aimed at conservation of resources. But this time, of precious rainwater. Low rock dams are being arranged to catch the water. But in this flat landscape, that requires a sensitive surveying device to detect the subtle gradients. This level uses a tube of water running between two measuring posts to align the dams. When the brief rainy season comes, the low dams will catch the water before it can run off. Then it can soak into the soon-to-be planted fields. The surveying level introduced by Oxfam was picked up by a regional conservation group dedicated to helping the Sahel's farmers, who are mostly very poor. It's led by Bernard Ouedraogo.
You cannot teach people things in a day, but bit by bit, they are learning. The proof is already there. People are really catching on.
One of the group's largest projects started with the manufacture of wire mesh. Then mesh containers were filled with rocks to construct this huge dam. Once again, rainwater collects here and soaks into the ground, enough even to replenish local wells. The wells last through the dry season, so that means vegetable gardens can now be grown all year. Here, the group offers training on how to conserve another resource. They're making compost from animal manure and crop residues. It provides fertilizer and preserves soil conditions. It's easy to assume that these simple measures, planting trees, conserving soil and water, being taken in the Sahel, are only needed by the poor farmers of the world. But America's lost soil, Australia's devastated rangeland, and Indonesia's rice disaster show that no farmer can afford to ignore how the earth works.
I'm going to call this good enough for number 36, and the end of this film gets into some details you don't need. But these examples that they were talking about in the Sahel region, Sahel Desert, Sub-Saharan Africa, I want to make sure everybody understood them. Wind protecting trees, shallow rock dams to trap surface water, and recharging groundwater with permeable dams. That's actually like really low tech stuff, and a lot of times we talk about how to help farmers in like our part of the world with modern technology or GMOs or better living through chemistry, but most of the planet's food is actually produced in conditions like this. Very minimal mechanization, very minimal automation, watering by hand, turning the soil by hand. So most of our global food solutions are probably in this style, not in the modern technology style. We have 4.5 minutes. Pre-lab questions, lab prep stuff, deep thoughts on life and love, interesting food system questions.